Hello, good morning. Now we are going to make a revision for the chapter 1, which is the motion of the first term. The motion is meaning first, what is the motion? The motion, if I have a body here, its position is A, and is going to transfer to another position, which is B. That's meaning I have changing in the object's position per unit of time. This is the meaning of the motion. So the motion again, the changing in the object's position per unit of time. Belong to the motion, we are going to take different concepts, which is first we'll take the speed, second we'll take the acceleration, third we'll take the distance, fourth we will take the displacement. Each one of them is including a meaning and rule, mathematical rule, to solve the whole equation. First we'll take the speed. What is the speed? The speed is meaning I have two concepts to describe the speed. the first, if you have an object also at the position A, and then this object transferred from position A till reaching to the position B, that's meaning the object covered a distance. This is the first factor. What is the second factor? The second factor is he will cover this distance through a certain period of time. That's meaning I have a time. So the two concepts that can describe the speed, which is the distance and the time. So it is the distance covered by the unit of time, or it is the change in the rate of a change in distance. Rate includes per unit of time. That's meaning this is the this is the meaning of the speed. What is the rule that will describe the speed? The rule that will describe the speed, we will take the triangle, which is a relation between the speed equal distance over time, and of course you can get the distance or you can get the time if you want. That's meaning if he's asking for the distance, equal speed times time. If he's asking for the speed, it equals distance over the time. What are the units for measuring the speed? The unit for measuring the speed will be, number one, the unit of distance, which is the meter or the kilometer per distance over time. That's meaning the unit of time. If this meter will be the second, and if it is a kilometer, it will be per unit of time, which is the hour. That's meaning I have two units for measuring the speed, which is the meter per second or kilometer per hour. If you are going to transfer from one unit to another, don't forget that changing from kilometer to per hour or meter per second, it will be a time from kilometer per hour. You are going to change it into meter per second. You have to time from kilometer to meter here, you have to time 1000. So 1000 will be in the numerator. The second one, per the unit of hour. So I'm going to change from hour into the unit of seconds, from here to here. That's meaning 60 times 60. Or times directly 5/18. This is if you are going to change from big unit to small unit, from kilometer per hour into meter per second. We have different types of speed according to the kind of the motion for the body and transferring from one position to another position. The first one will be if you have an object A, object at the position A, transferred into B, and then into C, covered here 100 meter, and covered it in 10 seconds. Then another 100 meter, also in 10 seconds. That's meaning this body is covering equal distance in equal interval of time. Equal distance, 100 meter, 100 meter. in equal interval of time, in 10 seconds, in 10 seconds. In this case, this body is moving with regular speed or constant speed. يعني this will be regular or constant. Sometimes you will find it as uniform speed. If you have a graph to explain this kind of motion, it will be relation between distance and time or relation between speed and time. If it is a regular speed, distance per unit of time, you will find it a straight line passes through the intersected point between the vertical and horizontal axis. If it is the relation between speed and time, it will be straight line parallel to the time axis. This is distance time graph represents a body moved with a regular speed. But this one, speed time graph, but represents also a distance body moved with regular speed or constant speed or uniform speed. All of them have the same meaning and the same rule. This is the first type of speed. The second type of speed, if you have a body at the position A, this is position A, till transferring to B, and then from B transferred to C. This is the kind of another motion. If here we have 100, for example, kilometer or 100 meter in 10 seconds, and then covered the second part 150 meter in 10 seconds, that's meaning this body is covering unequal distance in equal interval of time. If the body covers unequal distance in equal interval of time or equal distance in unequal interval of time, that's meaning this body is moving with irregular speed. Irregular speed or non-uniform speed. That's meaning, and also if you have something like that, you have to get the average speed, and this one is the third type of speed. The third type of speed is the average speed, and in this case you have to get the total or to calculate the total distance over the total time. Total distance over the total time will give you the average speed by the same unit, by the same speed. And this is the third type of speed. In case of if the body again covers unequal distance in equal interval of time, or is covering equal distance in unequal interval of time, that is meaning this body is moving with irregular speed. And if you want to draw the graph represents the regular speed, it will be a relation between a vertical axis and the horizontal axis. Vertical axis represents the distance and the horizontal axis represents the time. It will be like this. That's meaning, comparing to the other graph of regular speed, it was a straight line. But if you are getting the value of the speed here in different period of time, it will be a different value, because the body covers unequal distance in equal interval of time. The third kind of speed is the average speed. The average speed, it is the regular speed when the body covers equal distance in equal interval of time. This is the definition, while the rule of it is the average speed equals the total distance over the total time. I wish it is clear for everyone. The last type of speed is called the relative speed. Relative speed, this is a kind of relative. It's meaning it will be different from one person to another, but it has conditions. It has conditions is meaning what? If you have two bodies are moving in the same direction, A, and position B, or the car B. The car A in this case is moving with 100 kilometers. The car B is moving with 150 kilometers. Okay? And there is observer, a person, standing at the side of the road first. This is the first case. If the observer, I mean the person who's looking at the two cars, they are moving, don't forget, and notes that they are moving in the same direction, not opposite direction. If they are moving in the same direction and the observer is here in the side of the road and he is looking at the two moving cars, he will see that the first car is moving with 100 kilometers per hour. He will see the second car is moving with 150 kilometers per hour. That's meaning if he is on the side of the road, he will see each car with its speed. What will happen if this observer is putting in the slower one inside the car, and then the car B is moving beside it? He will see the speed of the second car with the subtraction of them, 150 minus 100. That's meaning he will see the second car is moving with a 50 meter per second or kilometer per hour, whatever the unit you have. Okay? That's meaning if you have two objects are moving in the same direction and the observer is in the first car or the slower one, we can see that the relative speed will be the subtraction between the two speeds. What will happen if they are moving in opposite direction? In the opposite direction, that's meaning the observer will see the second car by the summation of them, 150 kilometers per hour. If they are in the same direction, subtract them. If they are in opposite direction, add them. The other condition, if the two cars are moving with different speeds, with the same speed, and the observer in one of them, this is 100, and the other one is 100, he will see the other car as it is at rest. So the relative speed depends on the position of the observer. These are the different kind of speed. The second one is the acceleration. What is the acceleration? Acceleration, if you have a body at the position A, speeding up or speeding down, first he's moving from A to B, and then moves from B to C. Here is moving 100 kilometers per hour, and then from B to C he is moving, changing its speed to 120 kilometers per hour, and this changing in the speed take place within 10 seconds. That's meaning I have changing in the object speed per the unit of time. Changing the speed per unit of time, I have different values for the speed. From the part A, and then from B to C, 100 kilometers per hour, 120 kilometers per hour. This changing the speed happened within 10 seconds. That's meaning I have two speeds in one time. The first one of speed is called initial speed. Initial speed, which is called V1. And the ending speed, or the last one, is called final speed. Final speed, which is v2. And then changing the speed per unit of time, it will be v2, which is the final speed, minus v1, which is initial speed, over delta t, which is changing time of changing the speed. This will give you the acceleration. يبقى acceleration is meaning what? Again, acceleration is the changing in speed per unit of time. If the body starts its motion from rest, that's meaning the initial speed is equal 0. If the body is moving and then the driver uses the brake, after using the brake, the speed slow down and then stop. If he is moving and then stop, that's meaning the final speed is equal 0. And take care about these 2 points, because he will not give you in the problem the value of the initial speed if the body starts its motion from rest. And he will not give you the value of the final speed if the body uses the brake and then stop it. This is the acceleration. We have a uniform acceleration and non-uniform acceleration. If you are going to get this kind of speed, I have to make a third period. If the third period will be 140, and then this change within this period of time, that's meaning if we will use a third period to define this speed is uniform or non-uniform speed, I will add to this motion another motion, which is the third part from C to D. It will be 140 kilometers per hour. This is the third speed, within also from here to here 10 seconds. That's meaning here the rate of changing of speed is constant. The car is speeding up with a constant value, 100, 120, 140. Even if it is acceleration or deceleration, if the car speed is up, this is acceleration. If the car speed is down, this is a negative acceleration or deceleration. And the difference between them in the graph will be, this is the relation between speed and time. Straight line. What is the kind of acceleration here? The speed, changing the speed per unit of time is constant value, I mean per the unit of time. That's meaning this is a uniform acceleration. If the body is moving with a constant speed, if this one is distance and this one is time, and he told me what is the value of the acceleration here. What the value of acceleration here? The acceleration here is equal 0, because the relation between distance and time, here a straight line passes through the intersected point between the vertical axis and horizontal axis. That's meaning this regular speed. If the body is moving with a regular speed, is a constant speed. That's meaning there is no change in the speed. And if there is no change in the speed, that's meaning the value of acceleration equals 0. This is the acceleration. Beside, don't forget to know what is the unit of it. Meter per second square. Because speed over time. Speed, distance over time. And over another time. That's meaning the unit for measuring the speed, the acceleration, is meter per second or kilometer per hour square. And this is the unit of acceleration. Okay? This is everything, you have it. Just take care. If there is a deceleration. The acceleration is meaning that the speed of the body is slowing down. 100, 80, 60, and so on. Speed down is meaning deceleration or negative acceleration. If you have numerical value for the deceleration or the negative acceleration, it must be in a negative one. If he is writing the problem with a positive, change it into negative if it is a deceleration, and you will know it from the meaning of the problem by if the drive, for example, if the drive is moving with a certain speed and then use the brake. Using the brake is meaning the speed will slow down. The speed will slow down, that's meaning the motion I have it is deceleration, not acceleration. And deceleration is a negative acceleration. So the value number will be in a negative value. This is the meaning of acceleration. Now, the distance and displacement. I'll explain both of them together because they have the same meaning. They have the same unit, but different meaning. If the distance, that's meaning if the body is moving from point A till reaching to the point B, and this motion is 100 meters and covered it in 10 seconds, then he moved from B till reach to C, and this body covered 50 meters and covered it in 5 seconds, and then moved from C till reaching to D, covered also 100 meters and covered it in also 10 seconds. He finished its motion at the point D. So the A is the starting point. The D is the ending point. What is the difference between the distance that the body covered and the displacement? Distance that the body covered from A to B, from B to C, from C to D, and so on. If I'm calculating the actual path that the body covered from the starting point till reaching to the ending point, that's meaning I'm measuring the distance. So the distance without direction equals the first covered part is 100 meters plus the second part is 50, the third part is 100. That's meaning this body covered 250 meters, and this is the distance. If you are going to calculate the distance, it is the actual path that the body covered. Just your eye concentrates on the starting point and ending point, and the body moves within this area. But if you are going to calculate the displacement for this problem, just it is the shortest straight line between the starting point and ending point. Just join the starting point and ending point with the dots like that, and the distance between them will be the displacement. So the displacement here will be the same here because this one is like the rectangle. So displacement is equal 50 meters. This is the differences between distance and displacement. Distance, it is the actual path that the body covered without specific direction. But the displacement is the shortest straight line between the starting point and the ending point in specific direction. That's meaning this is the difference between the distance and displacement. This is why this one is a scalar quantity and this one is a vector quantity. By the way, the difference between the scalar and vector, scalar quantities, they are the quantities, the physical quantities that have a magnitude only. Magnitude is meaning numerical value without specific direction, without direction. While the displacement is the all physical displacement, one of the physical quantities that have numerical value, magnitude, and direction. You have 5 only, and the rest will be scalar. Displacement, velocity, weight, and force. Beside all of these, it will be scalar. But force is taking the direction. Weight, traction force. Distance with a specific direction. Velocity, this is the difference between speed. So the velocity will equal what? Velocity is the same like the speed. I mean in the measuring unit, but specifically with a direction. That's meaning if you want to get is asking for the speed and the velocity for this drawing or for this motion. Speed here 150, 100, this is average speed. And I gave and explained the rule of the average speed before. It was the total distance over the total time. The total distance is 100, 250, the total distance over the total time, 10 plus 5 plus 10, which is equal 25. I will get the speed. But if you are going to calculate the velocity, it will be the total distance over the total time. Here we are going to take the displacement, because there is a relation between the value of the displacement and calculating the velocity. So the velocity will be the displacement over also the total time. Displacement over total time is meaning displacement here, the value is 50. Over the total time will be the total time which is taken for covering the whole distance. 10 seconds, 5 seconds, 10 seconds over 25 seconds. And this is meter. And this is second. That's meaning the unit will be meter per second. And the same here, if you are calculating the speed, the unit will be also meter per second. This is the revision of the whole first unit about the physical quants, distance, displacement, speed with all different types. I hope that you understand everything about this one, and I wish that we will answer everything related to this unit. Thank you.